Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today we will create pipe fittings in Autodesk Inventor. Now we are showing two images of this model so that you can understand what these pipe fittings will look like at the end. If you want to get the file of this model, I have given the link address in the description of my video. By visiting that link, you can get it easily. Okay, that's it. Let's start the tutorial. First of all, we will create a Nipple model on here. Now we will start a new standard inch part file in Autodesk Inventor. Click Create. Okay, alright. Now we will activate the sketch tool from the design window. Create a sketch over the XY plane. Choose the front view by clicking on View Cube. Create a circle from the part origin and give the diameter of this circle 5 by 8 inches. We will choose the expression option so that it can be displayed in fraction form. Okay, now see the result. Finish the sketch. Choose the isometric view. Okay. Activate the extrude command from here. It will automatically select the sketch. Now we will select the symmetric option and set the extrude distance value 3 inches. Click OK. See, my first extruded feature has been created on here. Save the file, name it as Nipple in the pipe fittings folder. Select the nipple part and change the color of this part as light big. Okay, that's it. My model is looking perfect. Now we will activate the shell tool from here. Select these two faces of the model. And set the wall thickness value 1 by 16 inches. Click OK. Now see. Apply the chamfer over the front and back hole edge like this. The chamfer distance value will keep 1 by 16 inches. Okay, that's it. Create a new sketch over the YZ plane. Activate the section view from here and select the right view. We will take the project of the entire model by activating the project cut edges command. Okay, now see, and convert the entire sketches into construction geometry. Now we will open National Pipe Thread Profile power file from here. Okay. You can read the detailed description of this thread profile on here. Go to the Edit Sketch option. And select these three arcs on here. Copy the arcs and paste it into the Nipple power file. Okay, alright. Draw the lines from the end points of these arcs like this to close the sketch profile. Rotate the sketch 90 degrees like this. Okay, place the thread profile on this projected endpoint. Select all the sketch lines and apply the lock constraint on over it. Take the project of the z-axis by activating the project geometry command. Now my sketch is fully constrained, so we will finish the sketch. Rotate the model in isometric view. We will activate the Coil tool from here. See, the thread profile is automatically selected here in the design window. Select this line for coil axis. Next, we will select the reverse direction button from here and choose the cut option. Okay, alright. Go to the coil size tab. Select pitch and height from the list. Okay, fix the pitch value 1 by 14 plus 0.001 inches. Set the height of the thread, it will keep 9 by 16 inches and click OK. Now see, the actual thread is created over this feature. It looks great. We will mirror this coil feature over the opposite side of the part by activating the mirror tool. Go to the Inspect tab and activate the section view. Select the YZ plane, it will keep as a section plane. Okay, now see the result. The realistic thread is looking very fine. Okay, now my nipple part is completed on here. And save the file. Next, we will create a socket part on here. And we will create another new inch part file. Okay. Create a new sketch over the XY plane. We will go back to the nipple part and create a new sketch over the YZ plane. Activate the slice graphics command and take the project of the entire model like this. Convert entire sketches into construction geometry. Draw a rectangle on here. And fix the tangent constraint between this rectangle line and the projected arc. Now we fix another tangent constraint over the opposite side of the rectangle like this. Apply the coincident constraint between this line and end point of the projected sketch. Okay. Apply the horizontal constraint between these two endpoints. Convert the rectangle into construction geometry. We will fix the driven dimension over rectangle. In this driven dimension that you are displaying on here, we will use this dimension to make the inside hole of the socket. Okay, that's it. Go back to the part 2 file and create a circle from the part origin. Fix the diameter of the circle that we will measure previously. We will take an offset of this circle outside. The offset distance value will keep 0.0625 inches. Okay, alright. Save the part, name it as a socket. Okay. Start the extrude command from here. Select this sketch region. Choose the parametric option and set the extrude distance value 1.5 inches. Click OK. Now we will apply the chamfer over both side hole edges. Okay, it looks great. Start the sketch over the YZ plane. Take the project of the model like this. Now we will place the thread sketch profile on here. And draw the lines over this profile. Move the sketch over this endpoint. Okay, finish the sketch. Activate the coil tool and select this line for coil axis. We will select the reverse direction and cut option from here. And we will give the pitch and height values on here. And click OK to finish the command. Now see, coil feature has been created. Create a mirror of this feature over the opposite side. Activate the section view and now see. Okay, that's it. Now we will activate the tangent to surface and parallel to plane option from here. First of all, we will select this cylindrical face of the model, and then next we will select the YZ plane. Okay, now see, my work plane has been created here. Now we will activate the offset from plane command. Select this plane. Okay, choose front view and set the offset distance value. It will keep 1 by 32 inches. Okay, that's it. My second work plane has been created here. Okay, close the visibility of the back plane. And start the sketch over this plane. Now we will create a center point rectangle from the part origin. And we will create two arcs over the side edges of the rectangle like this. Now select these two lines of the rectangle and convert it to construction geometry. And we will fix the tangent constraint between this arc and this line. Okay. Apply the dimension 3 by 4 inches between these 2 points. And set the height of the rectangle 1 by 4 inches. Select this arc and this line and apply another tangent constraint between them. Okay, finish the sketch. And we will activate the extrude command. Select to next option and click OK to finish the command. See, my sketch is embossed perfectly. Okay, alright. We will activate the mirror command and select this extrude feature. Choose mirror plane and select the YZ plane. Click OK. Now see the result. My another extrude feature has been created over the opposite side. The socket part file is completed on here. Close the file. Next, we will create a third part file. Name it as a elbow. Okay. We will create another new part file. Click OK. We will start the sketch over the exact plane. Now we draw two lines from the part origin like this. And both the line dimensions will keep 1.5 inches. Activate the sketch fillet tool from here. Set the fillet radius 3 by 4 inches. And select this line and apply the fillet on over it. Okay, finish the sketch. Save the part with the name elbow. Now we will create a vertical work plane on this endpoint of the line. Okay, create a sketch on over it. Now we will create a circle on this point and give the diameter 0.53352 inches. And now we will take an offset of this circle 1 by 16 inches in the outward direction. Okay, finish the sketch. Now we will activate the sweep command from here. In the profile selection, we will select the sketch region like this. Okay, in the path selection, we will select this path and click OK. Now see, my elbow is created. Save the part file. Now we will change the color of this part as light black. And we will import the lightning style from here, which we have made before. It is looking very nice. Now we will apply the chamfer on the whole edge. Chamfer distance value will keep 1 by 16 inches. Okay, that's it. Start the sketch on the exact plane. We will take the project of the entire model and convert them into construction geometry. Now we will place the thread sketch profile on here. Okay. Create lines over the arc on here. Okay, alright. And move the sketch on this position. Now we will rotate the sketch 270 degrees. Okay, create a point on the midpoint of the sketch. And move the sketch from this point. Place the sketch over this projected endpoint. Now we will take the project of z-axis. Okay, that's it. Finish the sketch. Next, we will create a coil feature by selecting this thread sketch profile in the following way. Now my thread is created over the whole of the elbow. It's looking perfect. Now we will activate the parallel to line through point command from here. And select the center point. Okay, then select y-axis. Now see, vertical axis has been created. Next, we will activate the circular pattern tool. And first of all, we will select the coil feature from the browser bar. Okay. Then next, we will select the vertical axis. It will keep as a rotation axis. Set the occurrence count value to and set the rotation angle 90 degrees. And click OK to finish the command. Activate the section view by selecting the XZ plane. Okay, alright. You can see my second coil feature has been created over the opposite side of the model by using this tool. Okay, that's it. My elbow part is completed on here. So we will close the part file. Now we will create fourth part file, name it as T. Okay, alright. Create another new part file from here. And start the sketch over the XY plane. Choose the front view. Okay, draw a circle from the center point. And its diameter will keep 0.53352 inches. Now take the offset this circle. Okay, set the offset distance value 1 by 16 inches. Now we will choose the expression option from here. Okay, finish the sketch. Now we will extrude this sketch region 2.125 inches both equal side from the XY plane. Okay, now see and save the file with the name T. Now we will apply the chamfer over the part like this. Okay, now we will create a new work plane at an offset distance value 1.0625 inches from YZ plane and start the sketch on over it. Now we will draw the same sketch profile that we had done earlier on the base sketch. Activate the extrude command and select the sketch region. Select the reverse direction button from here. Now select to next option and click OK. You can see that the front hole of the inner wall is closed. We will remove this wall with the help of extrude command. Okay, alright. Open the visibility of sketch 2 and activate the extrude command. Okay, select the inner circle, choose the cut option. Okay, and then next select two option. Okay, rotate the model and select the inner hole face and click OK. Now see my hole is created over the T-part file. And we will apply the chamfer over the inner hole edge of this part. Okay, that's it. My T part is almost has been completed. In the same manner, we will create a thread over this part that we had done earlier on our previous parts. Okay, alright. Now we will create a mirror of this feature over the opposite side of the model. Create an axis on here. Okay. Now we will create a circular pattern of this coil feature like this. Activate the section view to check the result. Okay, that's it. Now my T part is completed on here. So we will close the part file. Now we will create fifth part file, name it as three-way elbow. Okay, alright. Now we will create an inch part file from here. And start the sketch over the XZ plane. Choose the top view. Okay, now we draw two lines from the part origin like this and give the dimension over these two lines. It will keep 1 inches. Okay, finish the sketch. Save the file with the name three-way elbow. Now we will create a new vertical plane over the end point of this line. And draw the circle on this plane. Its diameter will keep 0.65852 inches. Okay, alright, finish the sketch. Create one more sketch on the XZ plane and take the project of this line. Finish the sketch and close the visibility of sketch 1. Now we will activate the sweep command from here. See, my sketch profile is automatically selected on here and click OK. Now see the result. My sweep feature has been created. Now we will change the color of this part like this. And now we will import the color style from here. Okay. Now my part is looking very bright. Okay. Now we will draw a new sketch over the YZ plane. Rotate the model in this position. Now we will create a vertical line from the center point of the circle and its dimension will keep 1 inches. Okay, finish the sketch. Now we will create a work plane over the end point of this line. And start the new sketch over this plane. Now we will create a circle from this end point of the line. Now we will apply the same dimension over this circle that will be applied on my base feature. Okay, that's it. Finish the sketch. Now we will activate the sweep command and select the circle. Okay, now my second sweep feature is created on here. Hide the visibility of this work plane. Start the sketch over the XZ plane. Okay. Open the visibility of the sketch 1 and take the project of this line. Okay, finish the sketch. Now we will create another new plane over this end point of the line. Okay, that's it. And start a new sketch over this plane. Now we will create a circle from this end point. Okay, and give the diameter of this circle. Okay, finish the sketch. Now we will create another sweep feature like this. Rotate the model in opposite side. Now we will fill this empty area on here by using the sweep command. Okay, alright. So let's start the new sketch over the side face of the empty area. Okay, and take the project of these edges of the model like this. Finish the sketch. Let's start another new sketch over the top face of the empty area. Okay, and take the project of this curve. Okay, that's it. Let's start the sweep command and click OK. Now see here, my empty area has been filled by using this tool. Okay, it looks great. Let's start the shell tool from here. Shell thickness value will keep 1 by 16 inches. Okay, alright, and select the 3-hole face of the model. Click OK. Now see the result, my hole is created over the 3-way elbow part. We will give the chamfer on these internal hole edges on here. Okay, that's it. Let's start the sketch on the YZ plane. and take the project of the entire model. In the same way, we will create a realistic thread on the first hole of the elbow model in the following way that we had done earlier. And afterwards, we will create two more thread features on the remaining holes of this model by using a circular pattern tool. Okay, it's looking very fine. My three-way elbow model is completed on here. So we will close the par file. Finally, all the components of pipe fittings are finished here. So let's start a new inch assembly file on here. Click create button. Okay, that's it. Let's start the place component command from here. And place the Nipple model in this assembly. Save the assembly with the name pipe fittings. Next, we will place the socket and elbow components on here. Let's start the constraint command from here. Now we will select the XZ plane of the assembly and then next select the XZ plane of the socket. And fix flush mate between them. We will apply second flush mate between XZ plane of the elbow and XZ plane of the assembly. Next, we will place T and three-way elbow components on here. In the same way, we will apply the flush mate on these components that we had applied to the previous components. Now see, my mates are finished here and pipe fittings assembly has been completed in Autodesk Inventor. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. Okay friends, goodbye.